Hey, I am Subha, and in this video I am going to talk about electricity and chemical reactions. So please listen the English words until end. Electricity and chemical reactions. 0.1 Electrolytes. Substances that conduct electricity with simultaneous chemical changes either in the molten state or in aqueous solution as a result of the presence of ions are called electrolytes. These are ionic compounds in molten state or in solution. Besides, solutions of compounds which ionize in solution also act as electrolytes. Liquid metals, however, are not regarded as electrolytes since conduction takes place due to free electrons without any chemical change of the metal. Examples: acids HCl, SO, HNO, etc., alkalis, NO, etc., salts, NaCl, CaCl, CuSO, etc., conduct electricity either in the molten state or in aqueous solution and suffer chemical changes for which new substances are formed at the electrodes. Non-electrolytes, the substances which do not ionize and do not conduct current even in the molten state or in aqueous solution are called non-electrolytes. Most of the organic compounds belong to this category. Example: sugar, starch, urea, glycerine, petrol, kerosene, etc. These compounds do not conduct current either in liquid state or molten state or in aqueous medium. These are all covalent compounds. But pure HCl is a non-conductor in the liquid state, conducts current in aqueous medium. Strong and weak electrolytes. Depending upon the degree of dissociation, electrolytes are caused as follows. 1. Strong electrolytes. 1. An electrolyte which is completely ionized in aqueous solution is called strong electrolyte. Examples: mineral acids like HCl, HSO, etc., Bain, NaCO, etc., and salts like Nachi, NH, Canol, etc. They live solutions of much higher conductivity than weak electrolytes. 2. Weak electrolytes. An electrolyte which is not completely ionized in aqueous solution is called weak electrolyte. Example: most organic acids and bases like CHCOOH and some inorganic ions like NHO. Mechanism of electrical conduction in molten or solution state. Electrolysis. Electrolysis is the process of chemical decomposition of an electrolyte either in the fused state or in an aqueous solution by the passage of electric current DC through it. It is a process where electrical energy is converted into chemical energy. Electrolysis is generally carried out in a voltmeter. A voltmeter is usually a glass or porcelain vessel which contains the solution or the molten mass of the electrolyte and the electrodes. Ions. The molecules of an electrolyte in the molten state or in aqueous solution dissociates into positively and negatively charged particles called ions. The positively charged ion is called cation and the negatively charged ion is called anion. During electrolysis, cations migrate to the cathode and the anions to the anode. At the anode, the anions lose electrons and are discharged. At the cathode, the cations gain electrons and are discharged. Thus, oxidation occurs at anode and reduction occurs at cathode. Metallic conductors. These are the metallic substances which allow the passage of electricity through it without undergoing any chemical change. Some common amples are copper, silver, aluminium, etc. The conduction through metals is due to the movement of electrons in the metal's electrolytes. These are the substances which allow the passer AF elect through their molten state or through their aqueous solutions and also undergo chemical decomposition at the same time. Some common examples of electrolytes are acid, bases and salts. The conduction through the electrolytes 6 due to the movement light, generally referred to as electrolytic conduction. Electrolysis. Examples of electrolysis. 1. Electrolysis of water. Pure water is a very poor conductor of electricity. This is because of the fact that water molecule dissociates into H and O ions to a negligible extent. So, no measurable current flows on connecting the electrodes to a DC voltage source. However, addition of a little electrolyte, acid, alkali, salt, increases the conductivity of water to a considerable extent. Electrolysis of water may be carried out in an apparatus shown in Fig. 8.3.4. A glass vessel having 2 vertical platinum foils entered through the rubber cork that closes the bottom is half filled with water. A few drops of conc. HSO is added to water to make it acidylated. The foils are now connected to the positive and negative terminals of a battery and electric current sets in. It is observed that the bubbles of gases begin to evolve from the surface of the platinum foil. Anode. It is the anions loose electrons. Oxidation occurs. On passing the electric current, H0 molecule dissociates as H0H plus O. As a result of electrolysis, H ions migrate to the cathode, accept electron and is neutralized to form cathode. It is the electrode where cations hydrogen atom. 2 hydrogen atoms then form molecular hydrogen. O-lon on the other hand migrates towards anode, releases electron to form O radical that finally forms oxygen at the anode. Oxidation occurs at anode due to loss of electron and reduction occurs at cathode due to gain of electron. Hence the electron flows in the outer circuit from anode to cathode. The volume of oxygen collected at the anode is found to be half of that of hydrogen. 2. Electrolysis of copper sulfate solution using copper electrodes. A solution of copper sulfate in water is taken in a voltmeter provided with 2 copper electrodes which are connected to the 2 terminal of a battery Lug 835 GuSO, dissociates into Cu** and So ions. H0 also furnishes traces of hand O lons QSO, Cu plus so H0 equals HO. On passing electricity both hand kilona migrate towards cathode. Cu lon captures 2 electrons there, transforms to metallic Cu and deposits on the cathode. Thus the Cu electrode cathode becomes coated with copper and the mass of cathode increases. Now each copper atom of anode gives up 2 electrons and forms Cu lons. Thus the copper nu slowly dissolves and loses its weight. The rate of deposition of copper on cathode from QSO solution is the same as the rate of dissolution of copper anode into solution.
Hi, I am Shaly and I am going to teach you the application of this electrolysis. Well, applications of electrolysis. 1. Electroplating, in order to protect articles made of copper, iron, aluminium, etc. against atmospheric corrosion and also for better looking, superior metals like gold, silver, chromium, nickel, etc. are deposited on them by the process of electrolysis. The process of deposition of metals in a finely divided state is called electroplating. Procedure: the article to be electroplated is made the cathode. The electrolyte is a suitable electrolytic solution of the plating metal, and aqueous solution of the soluble salt of the metal is used. Rod or plate of the plating metal in pure form is made the anode. The article to be electroplated is thoroughly rubbed with sandpaper, washed with no acid and finally with distilled water. This is used as cathode, i.e., the spoon in Fig. 8.3.6. Electroplating is carried out in a tank made of wood, glass or cement. On passing electric current, the anodic material dissolves slowly and is deposited over the cathode material. Finally, the electroplated article is washed with water and dried in air. Examples: plating metal silver, gold, electrolyte, potassium dicyanoargentate 1, solution K, Ag, Cn, 2, potassium dicyanoaurate, 0, K, O, Cn, 2. Anode pure silver, pure gold. 2. Extraction of metals, when the molten mixture of alumina, fused cryolite, Al3, 3NaF, and some fluorspar, Ca, is electrolyzed, metallic aluminium is produced at the cathode. This principle is applied for extraction of aluminium from bauxite. The electrolysis is carried out in an iron tank lined inside with gas carbon which acts as cathode. The anode consists of a series of graphite rods suspended vertically and partially immersed into the molten electrolyte. At first a mixture of 60 parts of cryolite and 20 parts of fluorspar is taken in the cell and the mixture is melted. Pure alumina, 20 parts, is then added. On passing electric current, alumina is decomposed liberating metallic aluminium at the cathode and oxygen at the anode. The oxygen liberated at anode attacks graphite producing CO and CO, which are given off. 3. Purification of copper, metals like copper, silver etc. are usually purified electrolytically. In this method, the impure metal is made the anode and a pure sheet of the same metal is made the cathode. The electrolyte used is a soluble salt of the same metal. On passing the current, the metal ions from the electrolyte move towards the cathode. These metal ions gain electrons and the pure metal gets deposited on the cathode. The anions move towards the anode, lose the charge and dissolve. The impurities present in anode generally fall as mud. In the electrorefining of copper, impure copper is made the anode while a pure sheet of copper is made the cathode. The electrolyte is 15% aqueous solution of copper sulfate acidified with 5% sulfuric acid. On passing electric current, copper ions move towards cathode and pure copper is deposited over cathode.
Subscribe the channel for more videos, and like the video also. If you can't, then share the video.